Hello class, welcome to our lesson today dealing with section 6.6. We're going to be looking at discounts and markups. This is a good real-world application that many of us have to go through when we do things like going shopping and having coupons and taxes and things of that nature. So I think this is a very applicable lesson for everyone in the class. First thing we're going to do is just review some things about ordering numbers from least to greatest. Remember, if you have a bunch of decimals, percents, and fractions, probably the best idea is to get them all to be similar types. So either all fractions, all decimals, or all percents. I decided to make everything decimals here, so I took 2 divided by 3 and got 0.6 repeating. I took 3 divided by 5 and got 0.6. And 6%, I can divide by 100 and move the decimal back 2 spots, and that becomes 0.06. 6% has to be the smallest one here. It's the only one that has a 0.0, okay, or 0 after the decimal point, so it's the lowest. 0.6 is next, which is 3/5 because it's 0.60 if you keep adding more numbers in. And then 0.65, and then 0.6 repeating because it's 0.66, etc., which is higher than 0.65. The next one has some rational and irrational numbers. Remember, a rational number is one that can be written as a ratio or a fraction, so like 31 over 10 is 3.1. An irrational number cannot be written as a ratio, so pi goes on and forever and ever without repeating or ending, so that's why it's irrational. And it's 3.1415, etc. Okay, I put 3.14 here because it'll be enough to dictate where it goes. Square root of 8 is irrational because it's not a perfect square that's being square rooted. So if it was the square root of 9, that would be 3. The square root of 8 is something smaller than 3 because 8 is less than 9. So I don't know what it is, but it's smaller than all the others because it's 2 point something. And then 3.1 or 31 over 10 as a rational number goes next. The irrational number of pi is after that. And then root 17 has to be the highest, even though it's irrational. I don't know what it is, but it has to be at least 4 because the square root of 16 would have been 4. All right, today what we're going to look at is looking at discounts and markups. So this first example is just looking at 3 different situations and finding how much you paid for the item. So this says the regular price of the item was $45 and it's 40% off. Now there's 2 ways that you can solve this, but one of them is probably preferred long term. One way to find this is to find 40% of 45. I could do that by taking 0.4 or 0.40 times 45% of a number, and that would be 18. That's the discount, and then I need to find the actual price by taking 45 minus 18, which would be $27. That's one option. However, I think a different option is going to be helpful because when you have to go backwards as we go through these next 2 lessons, it's going to be better if you know how much you paid. I'm glad you know it's 40% off, but really we shouldn't care about what percent off it is. It should be how much we paid that matters. Stores are really good at saying, oh, wow, you got 30% off. But really, what you should be caring about is how much you paid, not what percent off it is. So when you're looking at this situation, if it's 40% off, that means I paid 60%. So if I take 60% of 45, that'll give me the $27 right away. Notice I'm doing the same thing. It's just a matter of what am I subtracting. Either I subtract the percentages or subtract the numbers. And my suggestion is to deal with the percentages because as we move forward in this lesson, when we have to work backwards, it'll be easier for you to work with. Next one is $49, same item, but it's 50% off. So 50% paid is the same as 50% off, so I just take 1/2 or 0.5 times 49, $24.50. So between A and B, B would be the better option. It's the same pair of sneakers, might as well buy it at the cheaper place. Then you get to letter C, which is typically what happens in retail. The regular price is $39 and it says up to 70% off. So if it was 70% off, I'm going to pay 30%. So you notice I did 30% times 39, and it's $11.70. The problem with this is the up to. And if you've gone to stores and you've looked at clearance racks and things like that, they always say everything up to 70% off. Well, there may just be a few things that are 70% off, and the rest of the items are regular price. So that's something to think about here, is that the fact that it's probably not 70% off. I mean, look how far off this is compared to the other 2. So maybe it was 30% off or something like that. The up to gets you inside the store, though. That's the goal, is to get you in to look, and then maybe you'll buy something no matter what. Okay, the next question is an example of why we want to know percent paid, not percent saved. You buy a shirt that's on sale for 30% off. You end up paying $22.40. You want to know the original price of the shirt. Okay, here we go. I know that $22.40 is the part. I'm trying to find the original amount, the paid amount. I know the paid amount is 100%, and I know what I paid for it is not 30%, it's 70%. So I should care only about the 70%. The 30% would be the discount, but I should care about the percent paid. So two ways that you could set this up. Part over whole, so I paid $22.40 out of the whole X equals 70 over 100, cross multiply and solve, and you'll get $32. I could also use the model from the percent equation. Part equals percent times whole. The part was 2240 equals 70% as a decimal is 0.7 or 0.70 times x. To get x by itself, I'm going to divide by 0.7 on both sides to get $32. This is where the idea becomes important, because if you were to do 30% and add it back in, it really doesn't work. Okay, and there's mathematical principles behind that, but you want to focus on percent paid. So in general, if you do every question the same and deal with percent paid, you should be able to get more questions right as you're going through these scenarios. The next one says you own a jewelry store, you increase the price of jewelry by 125%, and the reason for doing that is so you can make a profit. Okay, this is what happens in all stores. They buy something at wholesale price and then sell it for a little bit more. Okay, so my cost to get it is $250. That represents 100%. Then I'm going to add 125%. So my total selling price is 225%. It's a 125% increase, but the original 100% plus the 125 is 225. So really what I need to find is what's 225% of 250. So that would be 2.25 times 250. Part equals percent times whole. You could do the proportion as well. It will work. This should be a much higher number. $562.50 is reasonable because you're doubling at least that money to be able to find that answer. These next two are the exact same thing. You're increasing the jewelry by 125%. So remember, that makes it 225%. For this first one, it's a $50 item, so it would cost $112.50. For the second one, I did the percent proportion. My cost is $170. That represents 100%. Oh, excuse me. That represents 100%. I'm looking for 225%, and that represents X. So X over 170 equals 225 over 100. I cross multiply and solve to be able to find that answer. It's important when you find these answers that you make sure it's money related, so it always goes two place values. So if you get an answer of this one and it's 382.5, you have to make sure you add the 0 on the end to make sure it's 0.50 to round to the nearest hundredth or nearest cent. Okay, you're going to have a few questions that correlate to a table like this in your homework. The key is the original price is the whole, because that's what it originally cost. Percent of discount is 20% in this question. I want to know percent paid, though. So 20% discount, I paid 20%, and then I'm trying to find the sale price. That's the part. So it's really just part equals percent times whole, or the corresponding proportion. So that would be just find 80% of 20, and that's $16. And then think about it logically. If an item costs $20 and it's 20% off, it shouldn't be that much away from $20. So if you get a number that seems way off, you have to use kind of some logical thinking to figure out, oh, that's not right. That's probably the discount. I need to know the amount paid. Okay, so that's something to think about for this situation. Original price is the whole, percent discount, I want percent paid, so do 100 minus that number, and then the sale price. The next one says find the original price, so I'm looking for the whole. I have the percent discount is 75%, which means I paid 25%, 100 minus 75, 25%, and the sale price was $55.50. So that means my sale price, $55.50, is equal to 25% of the original. This is where you have to do your one-step equation, divide by 0.25 on both sides, and I should end up with an answer of $222 as the original price, which makes sense because it was so much discounted at 75% off that it should have been a pretty decent difference between the sale price and original price. Okay, when you're dealing with your homework today, you've got some groups of questions with the table that we just looked at and then some review questions. Remember, when you're given the discount, I would work and subtract it from 100% to figure out what percent paid you found or what you're looking at first, and then use that to find your answer. Also on number 29, you may just have to look up the relationship between the units given and figure out which one's lowest. Have a good day, everyone.